Little science quiz for you. Quick, how many planets are there? 9? Oh, no, wait, 8, right? Because we lost Pluto? Wait again, is it 9 now? Well, that's because this past week scientists announced they may have evidence of a 9th planet with a much more elongated orbit through our solar system that keeps us from seeing it for very long times. We're talking about a truly astronomically long orbit. So what if this discovery is confirmed? What would it mean for what's actually in our solar system? What's its implications for the former 9th planet, Pluto, something that was taught in schools for decades before the mysterious planet was demoted several years ago by scientists? Well, joining us now to try to explain all of this space stuff is Professor Frederick Walter from the Physics and Astronomy Department in Stony Brook University. Welcome to the show.
Thank you. Good to be here.
And you've been involved in studying this, haven't you? Explain your involvement.
My involvement is really, I've read the papers, and I teach about planets. I mostly observe exploding stars.
Yeah, so then you're aware of all the phenomena. Explain to our audience, first of all, what is the evidence for saying that there may be a 9th planet out there? And explain a little bit more about what kind of a strange world this is and where we think it is.
The evidence is gravity. About 20 years ago, astronomers started discovering Kuiper Belt objects. These are small objects the size of Pluto and smaller out in the general vicinity of where Pluto is.
And the Kuiper Belt is the outside ring, rocky ring that surrounds our solar system.
Correct. It's out past the planet Neptune.
Right.
So these objects, 2 years ago, Trujillo and Shepard, two astronomers, noticed that all of the orbits seemed to be going out in the same direction. The shapes are more or less the same, which is unusual.
So something's pulling on them? Gravity?
And gravity is pulling on them. Newtonian gravity, Newton's laws, Kepler's laws tell us very precisely how the planet should move. Gravitational pulls led to the discovery of Neptune in 1846.
So something is pulling on this. There's something, from their orbits, you can tell there's something else out there that's pulling on those planets' orbits.
It's a hypothesis.
Okay, so then how do we have any means of being able to observe if it's out there? Because we're talking it's way out there. And how long of an orbit would it take it to go around the sun?
The period of the orbit's between 10,000 and 20,000 years.
So that goes beyond most of our recorded history.
Certainly. And it's very faint, it's far away. The closest it gets to the sun is 200 times the distance from the Earth to the sun, about 1 billion miles.
But these are all mathematical numbers based on the gravitational pull you think you're measuring, right? Correct. So then they could change one way or the other when you're talking about this kind of theorizing. Is it also possible that it's completely wrong and there's nothing there?
Absolutely. This is the way science works. You observe a phenomenon, you make a hypothesis to explain it, then you test it. We're now in the testing phase.
Now, if there was something out there, wouldn't it be battling around with all the other objects flying around the Kuiper Belt? It's a pretty crowded area, isn't it? Or is it somehow separate from that?
Space is big, and the further out you go, the bigger the volume gets in the solar system. So the hypothesis is you have one massive planet, and you've got a lot of smaller things. We've discovered 13 of them, and it's pulling on these. Over 4 billion years, it's probably cleared out a lot of space. Flung stuff out of the solar system.
Now I was watching from the orbit there that it has this really elliptical orbit that perilously close to several of the big gas planets. Any chance of a collision there, or and how did you even come up with the idea that that's its orbit, since we've never actually seen it?
So two questions. One, it doesn't come close to the inner planets. The closest point is 200 times the distance from the Earth to the sun.
So that is
Neptune is at 40, Jupiter is at 10. So those are well inside. It will never collide with them. How do we know it's there? You run numerical simulations, you run models to try to explain if I have this distribution of objects in the Kuiper Belt, how do I explain that they all have orbits going in the same direction? If I put a planet out there with the mass of Neptune, with the period of 10,000 years, it can explain it.
So that also leaves open the door that it's possible there are other planets out there that somehow dip into our solar system that we haven't found yet, no?
It's quite possible. The solar system extends out halfway to the nearest star. Goes out 100,000 times the distance from the Earth to the sun. This is close. This is only 700 times that distance.
Close, relatively speaking. And so we're going to have new nursery rhymes to remember the planets if it proves that. If you're a betting person, do you think that there is a 9th planet there?
The evidence looks very strong.
Now, what does this all mean for Pluto? And explain to folks who haven't followed the plight of Pluto, what happened to it, and whether, first of all, were you in favor of demoting it from a planet?
Pluto is an oddball. Pluto is smaller than the other planets. It is, its orbit is more elliptical and inclined to the plane of the ecliptic than the other orbits, so it doesn't fit into the simple models of planets. Also, it's been gravitationally captured by Neptune. Its orbit comes closer in than Neptune is, and it goes further out. It goes around the sun twice for every 3 times Neptune goes around.
Is it a planet to you or no?
No, it is. Let me anthropomorphize this a little bit. If you were Pluto, would you rather be the runt of the planets or the king of the dwarf planets?
Right, that's a tough choice.
If Pluto was a planet, there's at least 13 other planets and probably 50 or 100 other planets. Would you want to memorize the names of all of them?
There are many rivals for the throne, as we know.
Yeah.
Well, space, it's a strange place to us, and, it can either make you feel insignificant or grand, I think. But I think it's wonderful that we're trying to find this out there. Last thing, I'm wondering, any theory that would work on trying to figure out what kind of a planet would it be? Would it be a giant gas planet if it is out there?
Yes, it would probably be a Neptune-sized planet. You need that much mass, so that's 5,000 times the mass of Pluto. It's much bigger, and Neptune's about 10 or 20 times the mass of the Earth. So it's a gas giant planet. We probably formed 4.5 billion years ago a number of these gas giant planets. We ended up with a stable solar system because Jupiter flung some of these things out to great distances.
Well, it just shows you the chaos of the early universe. Very old, yet very new to us. So we're just discovering these amazing discoveries of space. Thank you so much for helping us to understand a little bit. Professor Frederick Walter from the Physics and Astronomy world at Stony Brook University. Thanks for the trip into deep space with us this morning.